So solving quadratics by factoring. What we want to talk about is a principle of zero products. And that is, if an equation, a multiplication between two factors a and b is equal to 0 is true, it's only if a is equal to 0 or b is equal to 0 or both are 0. Now notice that this doesn't work if the product is equal to a non-zero number. So for instance, a times b is equal to something that's not 0. So I can tell that this would be true because if a is 0, then 0 times b would be equal to 0. And if b was 0, then a times 0 would also be equal to 0 because the multiplication of 0 yields 0. Or if they're both true, 0 times 0 is also 0. But would it work for something like this? A times b is equal to 4, which is a common thing that you see students do is they'll solve the quadratic equation for a constant and then they'll try to do the zero principal property. But it's not true because if I have the product of two things to be equal to 4, really there's an infinite amount of numbers that would make this true. So for instance, like 2 times 2 would equal 4, or 1 times 4 is equal to 4, or 1/2 times 8 is equal to 4, and 1/4 times 16 is equal to 4. And you can see that I can do this forever and ever and ever. So it doesn't yield any results if I have a product equal to a non-zero number. The only useful thing is if you have a product equal to a 0 number. So we're going to do some examples of factoring using the zero principal property. And here we go. All right, so we'll solve some examples by factoring. So these have already been factored for us. So once they've been factored, and I know that a factor is equal to 0, I can use that zero principal property. So what this says is this factor, we have a factor of 4, and we also have a factor of x. So either 4 is equal to 0, or x is equal to 0, or they're both equal to 0. And what we can tell is that 4 being equal to 0 is not a solution because for an equation to be true, the left-hand and right-hand side have to be the same. So the only answer to this is going to be x is equal to 0. And we can check. We can check. 4 times x is 0 is equal to 0. So 4 times 0 is 0. So this is our solution. Now this has also been factored for us. I have a monomial and I have a binomial. So this is going to be your a and this is going to be your b. I know the parentheses are redundant, but students like to see that separation between your two different factors. So either the first factor is equal to 0 or the second factor is equal to 0. Or they're both equal to 0. So that's why we leave both solutions as possible solutions. So this one's already solved. X is equal to 0 is done. Now I still have to isolate this one for x because it's a linear equation. You subtract 7, so 3x is equal to 7, and then divide by 3, so x is 7/3. So in the first equation, we only had one answer, but in this equation, we have two. We have x is equal to 0, or x is equal to 7/3, or both. All right, do two more examples. So these two examples have already been pre-factored for us as well, and then we'll get to factoring to be able to solve these. But if we have these in factored form, I know that I just have to set each factor equal to 0. So this is the first factor, we call it a, and this is the second factor, we call it b. So either the first factor is equal to 0, or the second factor is equal to 0. Now both of these are linear equations. We just isolate x in both cases. So x is equal to 4, or x is equal to -1. So those are our two possible solutions. For here, again, it's already been factored. So the first factor equal to 0, second factor equal to 0, and then we solve for x in both cases. So 2x is equal to 3, so x is equal to 3/2, and in this case, x is equal to -5. So our solutions are 3/2 or -5 or both. So now what we're going to do is maybe get to some examples to where we have to factor these things, and then we can solve them. So I'll write them up. So the next case is to the end of this lecture is we're going to have to factor these things first, and really just kind of keeping an eye on what is the very first step. So right here I have, actually in both cases I have a polynomial equal to 0, which is what we want to start out with because the zero principal property says that I want things that are factored that are equal to 0. Not equal to another number because that gives you an infinite amount of answers. I need resultant answers. So quadratics are going to give you two answers. So this is a binomial. So the first thing I look for binomials is I look to see if there's a greatest common factor. And then next I'll try to see if it's a difference of squares. So I'll start out with the greatest common factor first. I can see that it shares a 4 and an x. So factor of 4x from here, I'm going to get an x. Factor of 4x from here, I'm going to get a minus 8. And that's equal to 0. So the resultant is not a difference of squares. It's just a binomial with a power of 1 on the x, so a linear binomial. Now I have two factors equal to 0. So this 4x is equal to 0. If that helps you to see in parentheses, but that's your first factor, 4x. It's a binomial factor with 4x is equal to 0. And then this binomial factor, this 8 minus x is equal to 0. Now, solving for this, the way you get rid of a multiplication of 4 is you're going to have to divide by 4. So x is going to be equal to 0 divided by 4, and 0 divided by 4 is 0. Or you can tend to set it up as the zero principal property like we did before, either 4 is 0 or x is 0. We can see that x is 0. And for this one, we solve for x, so x is going to be equal to 8. So these are our two solutions. For this one, it's a trinomial. Now, trinomials, we know we have a method for. You can do the AC method, which is also called the grouping method. But really, when it's a 1x squared, we should be getting good at this. That I know that it's going to be an x here and an x here. And what I need is two numbers that multiply to 12 but add to 7. And we can see that 1 and 12, and it's got to become a positive 7. So clearly the factors are going to have to be positive. To be a positive number, either the factors have to match their signs, so both positive or both negative. So if this is a positive number, they have to both be positive. So 1 and 12 won't work, but positive 3 and positive 4 will. So 12 adds a 7, we're good. So set the first factor equal to 0, and then the next factor equal to 0, and then solving each one of these for x. So x is equal to negative 3, or x is equal to minus 4. All right, so I'll pause it. I'll do a couple more examples in here. All right, so in order to solve these two, we have to take advantage of that zero principal property. So this being equal to a negative 6x isn't helpful to us. So what I want to do is I need this to be equal to 0. So one way to do this is we're going to add 6x to both sides. Now, I want you guys to really try to not divide both sides by x, which is a common thing that a student wants to do. Because if you divide both sides by x, I'm going to break that over here. I'm going to show you what happens. We'll do it the correct way first. So adding 6x to both sides, I'm going to have x squared plus 6x is equal to 0. Now I see if there's a greatest common factor, and there's an x, and I'm left with x plus 6 is equal to 0. So we have x is equal to 0, or x plus 6 is equal to 0. This is solved, so x is equal to negative 6. Now, students, I've seen students try to do this. They're like, well, I can divide both sides by x. Now you can, what you'll have is, x squared divided by x is going to be this is equal to negative 6. But notice that you've lost a solution. When you divide things by a variable, you've got rid of the solution that makes that variable equal to 0. And we can see that 0 works. If I plug 0 in here, 0 squared is 0, and negative 6 times 0 is 0. So 0 equals 0 works. This is a solution. So if we do it this way, we lost it. You lost half your solutions. So when you see quadratic, set them equal to 0 and factor. All right, so factoring this one. AC method would probably be a really good way to do this. Or if you're good using the guess and check method, that's fine as well. But the first thing we know we're going to have to do is we're going to have to send this to the other side to make this equal to 0. So 5x squared plus 2x plus 3 is equal to 0. Now, many people would prefer to not have your coefficient as a negative 5. And since I'm allowed to send things to either the left or the right, we could put all of these terms to the other side, and that would make them all positive and send the 0 to the other side. So you can say 0, adding 5x to this side, subtracting 2x, and minus 3. It's the same thing as multiplying both sides of that equation by negative 1. So the solutions of this equation, the solutions of the other one will be identical. Now we can go ahead and do our AC method or our guess and check method. it might not be too bad since both of these things are prime numbers, so just to go ahead and use that guess and check method. So 0 is equal to, in order to yield a 5x squared, the first one's going to have to be a 5x, and the next one's going to have to be an x. Now, in order to yield a negative 3, one's going to have to be a positive 3 and a negative 3, so either this is positive or negative 3, either this is positive or negative 1, but we know that outside and inside have to come out with a negative 2, so probably a 1 here and a 3 here, because this will become 5 and this will become 3. Now I need it to be a negative 2, so this needs to be a negative 5 and this needs to be a positive 3. So let's make sure 5x squared, 5x to the negative plus 3x is negative 2x, and this multiplies negative 3, we're good. So now I have the multiplication of two factors equal to 0, so either the first factor is 0 or the next factor is 0. So solving for x, 5x is equal to negative 3, so x is equal to minus 3/5. And for the next one, adding 1 to both sides, so or x is equal to 1. So these are our solutions. All right, let's do one more involving a difference of squares, and then a couple involving where we have to expand first. All right, so I'm going to solve this. Notice that it's a quadratic equation because we have an x squared in here. So it means they're more useful when they're equal to 0, so that we can factor. So sending the 25 to the other side, I have 4x squared minus 25 is equal to 0. Now we can see that this is a difference of squares, that this is 2x squared minus this is 5 squared. So we know that it factors to a plus b times a minus b, where a is 2x and b is 5. So this is going to factor to 2x plus 5 times 2x minus 5. This will be equal to 0. So that means since the factors are equal to 0, either the first one is 0 or the second one is 0. So the 2x plus 5 is equal to 0, or 2x minus 5 is equal to 0. So here 2x is going to be equal to 5, and dividing both sides by 2 is going to be 5 halves. And here similar, this is negative 5, so minus 5 halves. And similar, 2x is equal to positive 5, so x is going to be equal to positive 5 halves. So there's our two solutions here. Now, I put this one on the board as your last example because really want to try to force ourselves not to misuse the zero principal property. Remember that the multiplication of two things equal to 0 forces that one of them have to be equal to 0. But the multiplication of two things being equal to a number that's not 0 doesn't tell us anything about these things. There's an infinite amount of numbers that'll give us 5 back. So what I have to have is I have to have this equal to 0 first. So the first thing I'm going to do is I'm going to get rid of the parentheses, because being factored equal to 5 is useless. So I'm going to expand first, set it equal to 0, and then refactor it. So x times x is x squared. Outside's minus 2x, inside's plus 2x. Last is going to be minus 4 is equal to 5. Now combining like terms, I can see that these two things will cancel. So I'm going to have x squared minus 4 is equal to 5. And finally, this is going to be x squared minus 9 is equal to 5. Remember, it's quadratic. It's more useful if it's equal to 0. So we're going to have x squared minus 9 is equal to 0. So now that it's equal to 0, I can factor these. Difference of squares. X plus 3 times x minus 3 is equal to 0. So this is going to give us negative 3. This is going to give us positive 3, because x plus 3 equals 0 means x is equal to negative 3. Or x minus 3 is equal to 0, which means x is equal to positive 3. And how about one more example, something similar to that for good measure. So one that's maybe not a difference of squares. So how about x plus 2 times x plus 5 is equal to, say, negative 2. So very similar to this, I have something that's factored equal to a non-zero number. So again, it's not useful to us. What we're going to do is we're going to expand this, and then I'm going to set it equal to 0 so that I can refactor it. So expanding these binomials on the left-hand side of this equation by foiling is going to give us x squared. Outside is 5x, inside is 2x, and last is going to be plus 10 is equal to minus 2. Now again, it's not useful unless it's equal to 0, so first we'll combine terms, and then I'll send that negative 2 back. So x squared plus 7x plus 10 is equal to minus 2. Send in negative 2 over, I have x squared plus 7x plus 12 is equal to 0. And I'm sure you've seen this one a bunch of times. Two things that multiply to 12 but add to positive 7 is going to be an x plus 4 times an x plus 3. Setting each one of these equal to 0, this factor is going to yield a negative 4, this factor is going to yield a negative 3. So x plus 4 equals 0, or x plus 3 is equal to 0. So x is equal to negative 4, or x is equal to